The goal of today's video is to start getting comfortable with ROS, and in particular to get some experience interacting with the ROS application using command-line tools. So first, let's talk for a minute about the components of a ROS application. So these are the main ideas that we have to get our head around to understand what's going on when ROS is running. So the first thing to understand is that ROS is a distributed system. So when we're running a ROS application, we're not running one program or one process. We're running a collection of processes that are interacting to solve whatever problem we're trying to solve with a robot. So these individual processes are called nodes. So for example, we might have one node that is a camera driver. So the responsibility for that node is to interact with the camera hardware and then communicate the images coming from the camera to other nodes. So we might have a second node that is responsible for planning a path for the robot, and maybe it's receiving images from the camera node and deciding what actions to take and then communicating that information to another node. So these nodes are attached to each other through topics. So we can think of topics as sort of pipes that we can connect between nodes that allow them to share information. And the information that is shared is messages. So messages are simple data structures comprised of type fields, and that's the actual information that the nodes share with each other. So there are quite a few different message types built into ROS. Things like an image message type, there are message types that just contain a string, or message types that just contain a number, etc. And it's fairly simple to create new message types if we have some new kind of information that we want to be able to share between different nodes. So to make that all a little more concrete, let's bring up ROS and take a look at a particular ROS node. So ROS core, that's the command that starts the ROS master. That's the process that manages all of the nodes and allows them to find each other. And the particular ROS node that I want to start is the Turtle sim node. ROS node run. Sorry, ROS run Turtle sim node. And notice I'm not typing all of these characters out. I'm hitting the tab key, typing a couple of characters and hitting the tab key, and then the command line will expand as far as it can. So if it's unambiguous, it'll expand the whole thing. If there are multiple options, it will list those options and I can pick the one that I want. So it's a good idea, it's a really good idea to get in the habit of obsessively using tab completion. It prevents you from mistyping some command that you're trying to run, and it also obviously saves you a lot of keystrokes. So here I've started the Turtle sim node. This is the sort of standard starter robot for getting a feel for the ROS system. Obviously it's not a real robot, it's a little simulated robot, and this green turtle is the robot. So what's actually going on from a ROS point of view? A good way to start getting a look at that is to run the rqt graph command. That's a program that will query the ROS system, find out which nodes are currently in place, and how they're connected to each other. So this is what we have right now. We have just one node. So in this particular graph, the nodes are represented as ovals, and the topics are represented as rectangles. So here we have one node representing our little simulated turtle. And then there are three topics. So this topic, turtle1, that's short for command velocity. That's the topic that we would communicate to, that we would publish to if we wanted the turtle to move. So we can see by the direction of this arrow that Turtle Sim is subscribed to that topic. It's listening for messages coming in on that topic. Here's a couple of topics that are being published by Turtle Sim, color sensor and pose. So these are the topics that the Turtle Sim simulator is using to communicate information about its state or about its sensor input. So this is a pretty boring computation graph. There's only one node, and nobody else is connected to those topics. So nobody's publishing to this topic and nobody is subscribed to these topics. So I've written a little ROS program that will communicate with the turtle by subscribing to the post topic to figure out where it is, and then sending messages along the command velocity topic to move the turtle. So let's run that. There it is, move turtle. And sure enough, the turtle is now moving in his little simulation window, and then he stops. So let's refresh our RQT graph application here, and we see it looks a little bit different now. Here's that turtle sim node that we saw before. It's still publishing those two topics. Now we have a new node. This is the node. This node is the node that was created when I ran my application. It's publishing to that command velocity topic, so that's why the turtle moved, and it's subscribing to the pose topic. So for some reason it's trying to figure out, or it's getting information about where the turtle is. So this is great. It often is the case that as we're developing some ROS applications, so for example, as I'm writing my move turtle program, things aren't working exactly as we expect them to. So it's important to be able to interrogate the system as it's running to debug, to figure out what's actually going on. So in particular, we'd like to be able to look at these topics and actually see the messages that are being communicated over those topics to see if they make sense. So for example, in this case, I might be confused by the fact that my turtle has stopped moving. So there are a couple of reasons it might have stopped moving, right? It might have stopped moving because the turtle sim is broken somehow and it isn't listening to those messages. It might have stopped moving because my turtle mover node stopped communicating those messages that it was using to move the turtle. So without being able to investigate what's going on, it's hard to figure that out. So the best way to do that in general is to use a set of ROS Command-Line Tools, and they all have this ROS prefix. So the first one we might be interested in is ROS Node. So as you might have guessed, ROS Node is a command line tool that can be used to interrogate the set of nodes that are currently active in the ROS system. All of these tools have a help option, so if I just say -H, it'll give me the commands associated with that tool, so ping, list, info, kill, etc. So in this case, I might be interested in listing all of the currently active nodes. And there they are, there are 4. But that might seem a little bit confusing. So I see turtle sim, that's turtle sim. I see turtle mover, that's turtle mover. But there are a couple of additional nodes that are active too that actually aren't showing up in this graph. And that's just because I have my graph configured to hide some of the information that it could show me. So for example, it's hiding nodes that it considers to be debugging nodes. So that's our ROS out and our RQT GUI Pi node. So that's actually the node associated with this RQT graph thing, which we don't necessarily want to see in the RQT graph, but we can turn it on if we want to, and we see that here. So let's turn those back off. So that's the full list of nodes. I can also do something like ROS Node Info turtle sim. So I can query the ROS node for some specific information about a node that I'm interested in, so in this case turtle sim, and it gives me all kinds of information. It tells me about services that it will pay attention to, topics that it's subscribed to, topics that it's publishing to, and it also gives me some information about what other nodes are connected to those topics. So for example, we can see here that it's publishing the turtle pose topic, and turtle mover is subscribed to that topic. So a lot of the same information that we were able to get from that graph, we can get from the command line here. But what I'm really interested in at this point is investigating this command velocity topic to figure out what's going on with that. And the command for interacting with topics, or for learning about topics, is, as you might expect, ROS Topic. And again, if I give it this -H flag, I get a list of all of the options, all of the possible commands I can use with ROS Topic. Excuse me. And the one that I'm interested in right now is ROS Topic List. That will allow me to just list all of the topics that are currently in existence. And again, here we see command velocity, so there's one there, color sensor, there's one there, pose, there's one there, and again, we see some of these that aren't showing up in the graph because they're debugging topics. There are additional flags that we can use, and I can get more information about these commands. So ROS Topic List has several options itself. One of them is this verbose flag. And if I do that, I get a little bit more information about those topics. So for example, color sensor, it's telling me that has one publisher, and it's also telling me the message type associated with that topic. So if I want to get as much information as possible about a topic, I would do something like this, ROS Topic Info, and then I list the topic that I'm interested in. So I'm interested in turtle, command velocity. Notice I am tab completing every time. So here's the information about that topic, who's subscribed, who's publishing to it. And what's really interesting for our purposes is this is also going to allow us to see the message type. So these topics are typed. There's only one kind of message that should be communicated along a particular topic. And in this case, it's this twist message. Well, what is a twist message? What sort of information is stored in a twist message? As you might have guessed, there's a command line tool for investigating these messages, and it's called ROS MSG, ROS Message. And it has several different tools associated with it, several different commands. So the ones I might be interested in here is probably show. So I want to see that message type to see if I can figure out how to interact with it. So ROS Message Show. And the name of that message was geometry messages, so that means it's in the package of geometry messages, and the particular message type is named twist. So I need to provide the package and twist. And this will show me all of the fields in that message type. So in this case, it has two fields. It has a vector 3 named linear and a vector 3 named angular. Vector 3 itself has 3 fields, so there can be some nested structure in these messages. A message can be composed of other message types, and that's what we're seeing here. So this thing has a linear field, which has the X, Y, and Z fields, and an angular field, which has the X, Y, and Z fields. It's not clear from looking at this how I should interpret all of that information. Sometimes I can get some more details by using the -r flag or the --raw flag. And what that shows me is the actual contents of the file used to specify that message type. And that can be useful because very often those files will contain some comments describing the message type and how we should interpret the different fields. So in this case it says, this expresses velocity in free space broken into its linear and angular parts. So we can interpret these X, Y, and Z's as velocities. These linear ones are linear velocities along those axes, and the angular values are rotational velocities around those axes. So great. So my original question was, what's going on? Why is the turtle not moving anymore? Well, one thing that I can do is I can listen in on these topics from the command line. So ROS Topic Echo is the command for that, and then I provide the topic that I'm interested in, turtle, command velocity, and there we go. We're seeing now these messages appear in the terminal. These are the actual messages that are currently being transmitted along that topic, and so now we can sort of see what's happening. So these messages are being communicated, but all of the fields are 0. So that's why the turtle isn't moving. So turtle mover is repeatedly sending a message along, which is telling the turtle sim not to move. And now I can hit Control-C to stop that. It's just going to keep dumping those messages to the screen until I do. So Control-C is sort of the universal way of stopping a Linux or a Unix terminal program and it should work for all of our ROS commands. So that's great, I've learned something, but maybe I'm still not totally confident that my Turtle sim program is actually paying attention to those twist messages. So let's, for a second here, stop move turtle, refresh that, it's gone. And now I want to, from the command line, send a twist message into this topic so that the turtle sim who is subscribed to that topic will receive it and the turtle will move. So I could write some code, some Python or some C++ code to send those messages, but often for debugging purposes it's useful to be able to sort of manually do that from the command line. So how does that work? Well, I want to send a topic, send a message to a topic, so the command is ROS Topic pub for publish. So I want to publish a message on this topic. I need to provide several arguments on the command line. It can be hard to remember what they are, so of course I'll use tab completion. Looks like the first one should be a topic, and I want command velocity. And I just hit tab twice, and it automatically filled in the next two fields. The first field was the message type that we should be publishing, and it was able to infer that from the topic that I want to send a message to. And then I need a string representation of one of those messages. And then when I hit tab, it automatically filled that in for me, and now I can go back and I can edit that. So I'll say x1. So I'm telling the turtle to move forward at a velocity of 1. If I hit enter, sure enough, the turtle moved. So I'll do that again, keep an eye on the turtle. He moved. He just moved a little while and then he stopped. That's just how this particular robot works. Every time it receives a message, it follows the orders of that message for a while, and then it will stop and wait for the next message. So to recap, those are really the main tools that we need to understand to be able to make sense of a ROS application or a ROS system while it's running. ROS Node, ROS Topic for investigating the list of topics, and ROS Message for figuring out what information is stored in the different messages that are being communicated. All of these tools have equivalent way of doing those same things using a GUI, and that GUI is called RQT. So if I bring up RQT, let's close that. RQT has a large number of plugins associated with it, and there are plugins for doing the same kinds of things that we just did using the terminal. So for example, if I wanted to echo a topic, that's where we were watching those command velocity messages. The Topic Monitor plugin does that same thing. It's listing all the available topics. I can choose to monitor one by selecting it. And then if I open it up, I can actually see the latest message that was communicated on that topic. It's also showing me some additional information, the fact that those topics are being sent out at 60 Hertz or a little more than 60 Hertz, the amount of bandwidth being communicated along that topic, etc. So feel free to use that RQT tool. I tend to find it to be a little bit clunky. For me, for most of the things that I want to do, the fastest way of getting the information I need is using those command line tools. So I encourage you to get comfortable with ROS Topic, ROS Node, ROS Message, etc.